Okay, so now what we are going to do is, so far we focused on undirected graphs. So we did both breadth first search and depth first search on undirected graphs. So let us now focus on directed graphs, so where each will have a direction, and we'll see how to run depth first search on directed graphs. And there's a lot of applications, as we'll see some of them very important and interesting. Okay, so again we're going to use a stack to keep track of the vertices that are visited. So if you're given a graph with the node vertex IDs as alphabet, again you can break the tie using the lower alphabet ID. So we'll start, say, with vertex A, the depth first search. So push vertex A to the stack. Vertex A is the first vertex to be pushed to the stack. So now from vertex A, you could visit vertex either B or C. So again you break the tie by going to a lower ID, lower alphabet neighbor. So you go to vertex B. So you push vertex B to the stack. Now, so vertex B has been visited for the first time. So we call the edge from A to B as a tree edge. So again the definition is as usual. We visit a vertex for the first time in the traversal process using that using an edge. Sorry, excuse me. So then that edge can be called a tree edge. So you push vertex 2 to the stack. Sorry, vertex B to the stack. So vertex B is the second vertex to be pushed to the stack. Now from vertex B you try to go somewhere else. So you see now, in the case of vertex B, you have an edge that goes to A as well as an edge that goes to C. Now you see this edge from vertex B to A is an edge like what? This vertex A has been already visited, and not only that, we have to be very specific here. This vertex A is still in the stack. It is pushed but not yet popped out of the stack. So if you visit a vertex using an edge that is still in the stack, then that edge should be called a back edge. Again, the same as what we did for undirected graph. But you have to be very careful to identify whether that vertex is still in the stack or not, because later we'll come across a different case. So in this case, from B to A, so it started from A, pushed A to the stack, that's the first vertex we pushed. So visited B as one of the outgoing neighbors. So vertex B was not visited so far, so we pushed vertex B, the second vertex to stack, call that edge AB as a tree edge. So now the top of the stack is B. So we are at B and try to visit somewhere else. Now when you look at the edges going out of B, you have an edge that goes to A. So this edge, this vertex A is already pushed to the stack and it's still in the stack, not yet popped out. So we should call this edge as a back edge. Now this edge to C, so we cannot go to A because it's already pushed and still in the stack. So now we'll try to go to some other vertex. So let us look at this edge BC. Now C is a vertex that has not been yet visited. So if you visit a vertex for the first time using that edge, using an edge, then that edge can be called a tree edge. So we call this BC as a tree edge. So now we push C to the stack. C is the third vertex to be pushed to the stack. Now from C we cannot go anywhere else because it's like there are no outgoing edges from C. So we are like a dead end. As usual, we pop out the vertex from the stack. So C is the first vertex to be popped out of the stack. So now we are back to B, which is the top of the stack. Now from B we cannot go anywhere else because we have classified both its outgoing edges. One as a tree edge, this is a back edge. So this is a tree edge and this is a back edge. Now so we pop out B also. So now we are back to A at the top of the stack. Now you have an edge from A to C that has not been yet classified. Now you see the difference. This edge is to a vertex that has been already pushed as well as popped out of the stack. Okay, so only in directed graphs we will come across these two different cases. One edge is to a vertex that is pushed and it is still in the stack. We call that edge as a back edge. Now we have an edge to a vertex that has been both pushed as well as popped out of the stack. So we should call this edge as what is called a forward edge. So we should not call it as a back edge, because back edge means, in the case of directed graph, that edge should be still in the stack, not yet popped out. But in this case, we have an edge from A to C, so the destination vertex, the target vertex C, has been pushed as well as popped out. So C should be, the edge from A to C should be called a forward edge. Okay, so again we cannot go to C because it's already pushed and popped out, so we are at A and we cannot go anywhere else from A. So it's time to pop out A also. So A is the third vertex that is popped out of the stack, and the stack actually is empty now because it started with A, went to B, then to C, then popped out C, then B and A. So the stack is empty. So that means we started depth first search. So we can call it as one instance of depth first search. We ran one instance of depth first search starting from A, and we were able to visit B and C. And you notice there are still D and E in this graph, not yet visited. So in order to explore or visit D and E, we have to start another instance of depth first search. We cannot visit D and E in the same instance of depth first search we started with A. So that is now we are going. That means you have to now start a new instance, another run of this depth first search program. So that's what I mean by instance. When you have to run depth first search again from an empty stack, starting from an empty stack. So we start, say, from again among the two vertices that are yet out there. We start with pick the lower alphabet. So we'll start from D. So we push D to the stack. But we'll continue the push and pop numbers. So far we pushed and popped 3 vertices. So D is the 4th vertex to be pushed to the stack. But again, remember the stack is empty. We are pushing D to the empty stack. So D is on the top of the stack. So from D we try to explore and go to outgoing edge. Using outgoing edge, go to a vertex that has not been visited yet. So you have 2 outgoing edges from D, one go to C, one going to E. Now this edge that goes from D to C is what kind of edge? Now this edge is visiting a vertex C that has been both pushed as well as popped out of the stack. But when? C was visited in an earlier instance of depth first search. So again, because of that, it cannot be called even a forward edge. It should be called something different. It should be called what is called a cross edge. So cross edge means you have an edge going to a vertex that has been visited in an earlier instance of depth first search, some previous instance of depth first search, not in the current instance. So why I say we did not visit the vertex in the current instance in the case of cross edge. Like look again, go back to this example, the case of A, B, C. He started from A, went to B, then to C. So C was visited, pushed, popped out B, then back to A. Now this edge from A to C goes to C, which is a vertex that has been pushed and popped in the same instance as this A, starting from which we are having the edge from A to C. So both A and C kind of were visited in the same instance of depth first search. So if you have an edge to a vertex that has been pushed as well as popped out in the same instance of depth first search as the other end of the edge, the other vertex end of the edge, so we call that edge as a forward edge. But in this case you have D that is visited now in the current instance of depth first search. You have an edge to C which was visited in an earlier instance of depth first search. Then that edge DC should be called a cross edge. So it's like an edge crossing between the two instances of depth first search, between the current instance and some earlier instance of depth first search. So such edges should be called a cross edge. So again, we cannot go to C because it's already visited. So we try to go somewhere else from D. So in this case, we can go to E, which has not been yet visited. So we are visiting E for the first time. So the edge DE should be called a tree edge. So we push E to the stack. That's the fifth vertex to be pushed to the stack. So now from E, we try to go somewhere else. We cannot go anywhere else. So we pop out E. That's the fourth vertex to be popped out of the stack. And then the top of stack is now D, so we cannot go anywhere else, so we pop out D also now from the stack. That's the fifth vertex to be popped out of stack. So we continue with the push and pop numbers. Now so far we did not apply this push and pop numbers for any application, but right after we look at the directed graph, we will look at an application where we use the push and actually the pop numbers. Okay, so right now we should be clear with how to classify the edges in the case of directed graph, how to classify the edge as one of these four categories: tree edge, back edge, forward edge, and cross edge. So in this slide, actually I have given out explicitly, I have worded out the scenario when we call each edge as what. So tree edge is an edge to a vertex that has been not yet visited. Back edge is an edge to a vertex that has been already visited in the current instance of depth first search, and the vertex is still in the stack, which means it's not yet popped out. It's pushed but not yet popped out. So that such an edge is called a back edge. Forward edge is an edge to a vertex that has been visited already in the current instance of depth first search. It means the vertex has been already pushed as well as popped out of the stack in the current instance. In the case of cross edge, the vertex is already visited in an earlier instance, some other instance of that first search. Alright, so I have a graph here to again illustrate this. So let us do depth first search again on this graph. So here we have the numbers. So we'll start with the lower ID number, which is V1. So from V1 we can either go to V2 or V3. So we'll pick the lower ID neighbor, we'll go to V2. So V2 is a vertex that has not been yet visited. So we'll call this edge as a tree edge. So we start with V1. So push V1 to the stack. So now go to V2. So push V2 to the stack. So top of stack is V2. So from V2 we can go only out to one other vertex. So we have to pick V3 again, that has not been yet visited. So we push V3 to the stack, that is the third vertex to be pushed to the stack. Now from V3 the only outgoing edge you have is to V1. Now you think about V1. V1 is a vertex that has been already pushed to a stack but not yet popped out, because we started from V1, went to V3, then went to V2 and then to V3. So that means V1, V2 are both still in the stack. So that means that edge should be called a back edge from V3 to V1. Okay. Now again, also as last class I said, if you want to find out whether the graph has a cycle or not, I said if as you do depth first search, if you come across a back edge, then that means you have a cycle in the graph. So that is applicable here too for directed graph. So when you encounter a back edge, that means you have a cycle in that directed graph, which is in this case the cycle is say V1, V2, V3. So you can start from V1, come back to V1. That means you have a cycle. Alright, so we cannot go anywhere else from V3 because there's only one outgoing edge and that's a back edge. So we'll pop out V3 from the stack. So V3 is the first vertex to be popped out of the stack. So back to V2 at the top of the stack. We cannot go anywhere else from V2. So we pop out V2 also. Now back to V1 at the top of the stack. So now you have an edge from V1 to V3. So this edge from V1 to V3 is an edge where this V3 is already pushed and popped out in the current instance of depth first search, right? Because V1, the other end of the edge, is explored in the current instance of that first search, and V3 is also explored in the current instance of that first search. So both V1 and V3 are visited in the current instance of that first search. So now V3 is a vertex that has been pushed as well as popped up. So we call the edge V1 to V3 as a forward edge. Again, it's not a back edge because V3 is not still in the stack. It has been already popped out of the stack. So V3 should be called a forward edge. Now the presence of forward edge doesn't have anything to do with the cycle. So only back edges are associated with cycle. So don't confuse between the two. Forward edge is not associated with cycle. Again, the scenario when you call an edge as a forward edge is if both the end vertices are visited in the current instance of that first search and the destination and the target end. So in this case V1 to V3, we can call V1 as the source end and V3 as the destination end or target end. That vertex V3 has been already pushed as well as popped out. That means it's called a forward edge. Alright, so we cannot go anywhere else from V1, so we pop out V1. So V1's third vertex to be popped out of stack. So actually the stack is now empty because we started with V1, went to V3 and V2 and V3 and popped out V3, V2, now we popped out V1 also. So the stack is empty. So that means in this current instance of that first search starting from V1, we are able to visit only V2 and V3 and not yet V4. So that means in order to explore V4, we have to start depth first search again, a new instance of depth first search. So we'll start depth first search starting from V4. So stack is empty, you push V4 to the stack. So again, but we continue the push and pop numbering. So V4 is the fourth vertex we push to the stack. Now from V4, you have two outgoing edges going to V2 and V3. Now what should we call these two edges? That's what we have to find out. Now V2 is a vertex that has been already visited, but not the current instance of that first search. The current instance of that first search, you are just starting from V4 and you did not visit any other vertex. So V2 was visited in an earlier instance of that first search that started with V1, went to V2, then V3 and so on. So that was the instance of that first search during which you visit V2. So that is why this edge from V4 to V2 should be called a cross edge, because V4, which is the source end of the edge, is visited in the current instance of that first search, and V2 was visited in some earlier instance of that first search. So it's called a cross edge. Similarly, the edge from V4 to V3, V3 is also visited in the earlier instance of that first search, not the current instance. So we should call V4, V3 as a cross edge. Okay, so you should be very familiar with this. Given a directed graph, you should be able to run depth first search and identify the edges into one of these four categories. Okay, so let me stop if you have and save this video. If you have any question,